Hello, welcome. We're here to discuss architecting and selecting the best system for AI applications. You may have struggled with how to architect a system for your AI application. We see many end users like you struggling with these issues every day, and I feel your pain. In this session, our intent is to arm you with a map and a toolkit to do this skillfully and better. You'll probably groan about another vendor pitch. So here's my promise to you today. There will be no 20-minute buy my server only presentation during our time together. It's not who we are, it's not who I am. But instead, we'd rather offer some practical advice and a system on how to architect your next AI system and how you may want to operate when you're looking for this next AI hardware deployment. So with that said, why should you believe I can tell you anything about this? Well, I architected HPC clusters and GPU systems for 6.5 years at Microwave, working with many thousands of customers and on hundreds of different deployments. And then I moved to the IBM HPC group and led HPC product marketing for power servers, those used in the Coral deployments, Summit and Sierra. I also helped start the marketing of AI hardware and software there, i.e. Power AI, the software toolkit for AI in that same division. And how about Microwave? Well, we're a longtime HPC and AI systems integrator. We have 38 years of serving the HPC community. We were one of the first to jump on GPU computing hardware in the 2007 to 2008 period, before the Tesla GPUs even existed. We're an early leader in AI systems. And I'm today part of a technical team full of people who design and deliver a huge quantity and, more importantly, diversity of AI and HPC hardware. So today we're going to talk about what do you do before you start this exercise of selecting an AI system? Where do you start this journey? How to select a system for a few different workloads, and then finally, how to collaborate and even navigate the relationship with vendors. So, who is this presentation for? This is for the type of end users who don't know where to start, need a checklist or a system for how to select this next piece of AI hardware. If you're a domain scientist or a practitioner first, and this pesky hardware stuff is a necessary evil. If you're afraid of or you hate working with vendors, well, this is for you. This is most definitely not a presentation for those who are AI framework writers. You're going to know way more about GPU hardware architecture than these high-level guidelines will help with. It's most certainly not for a 10+ year Ninja GPU coder. Again, you know far more about mapping to hardware architectures than any high-level guidance here. So, the first question to ask when architecting a system before you start is pretty simply, what do you know? What do you know about quite a few things? So first subset of that is, what do you know about your data set? How about its size overall? Does it fit into a single GPU? What kind of GPU? Or is it definitely a number of GPUs? Or is it so large that it's a multi-system? What is the overall size of the data set in aggregate? Second, is it chunkable? The professional term for this is batch size, but overly simplistically, does your data divide or fit into chunks the size of, say, a GPU or a portion of one? The third is, what is the size of each individual data? Sometimes your data is so large it won't fit inside of a GPU at all. That's a case for a specialized algorithm or some kind of specialized hardware architecture to compensate. So on the right-hand side, you'll see a visual of, taking a look at your data set. This is grossly oversimplified, but it's a nice way to think about each of these parameters. On the top, you'll see an overall data set that's 320 gigabytes large, made up of these Mona Lisa images. Next, one level down, you'll see how this data set could be chunkable, right? How you could break it up into different batch sizes that fit on a single GPU, 80 gigabytes maximum. That's a case for a multi-GPU server architecture. And then going one layer down, thinking about the size of each individual piece of data. Well, say you don't have that beautiful data set at the top that's 320 gigabytes large and full of all these smaller images, but in fact you have individual images that are 320 gigabytes a piece in size. Well, now you have to start thinking of an hardware architecture that uses NVLink or NVSwitch to allow you to address that very large data size. So Next, what do you know about your algorithm? What's going on internally? Pretty simply, what is it? You can think about this as kind of being on a plane. At the left, you have a standard AI framework that may dictate a denser and more NVLink interconnected system that has a performance benefit on training. Next, you have a mixed workload that necessitates a more balanced system. And on the far right-hand side, you have a completely custom algorithm. You control how it works. You can map the algorithm to the system architecture with the greatest performance in a high system density. So you can think about PCI Express switching being a really good candidate for this. So how do you learn about your code and how it works? Well, you use some very capable tools. NVProf, the Alinea performance tools, the NVIDIA CUDA Visual Profiler to help do an analysis of the workload. And that will help you understand what kind of hardware architecture to implement and deploy. Then, what do you know about your collaborators and your other users? End users underweight this by far. They're so focused on the concrete hardware value, how much they need to spend, what's a complicated price performance calculation for it, that they miss this efficacy metric. If you and your primary collaborator need to dramatically change your data prep steps or even your runtime instructions to perform the same runs and work together, then you're getting far less time out of your expensive hardware investment. So you may want to map your hardware investment to be more similar to theirs. So what are your collaborators running on hardware-wise? If they're using a larger facility for larger runs, or you are, and you have dedicated time on a larger machine, matching this may be critical for deploying the right kind of hardware architecture for AI application. And then finally, what kind of resource is this? Is this a semi-dedicated resource for you in a small group? Is it a shared resource for across the institution? This too may guide your hardware architecture. For example, Milwaukee School of Engineering, they deployed a teaching and production cluster called ROSI. The hardware architecture changed substantially from what it was initially thought about as, because it included many more small GPU and lower density systems, because it was a shared resource that was being used for teaching as well as AI production. So where do you start when you're embarking on this AI hardware architecting? Well, the first thing is put to paper, what do you want to run on the hardware? The workload for hardware purchase, it may not be monolithic. It may not be just one thing. You may have a workload that's AI training only. That's kind of the far left of, again, this same spectrum. You may have a mixed HPC workload. Well, that's a diversity of things that are running on the hardware. Or on the far right-hand side, you may have a completely custom algorithm. Each one of these will necessitate a different hardware architecture. So just simply put to paper, what do you want to run on the system? And that's actually going to be very useful for helping you guide the system hardware architecture. And then the second thing that you should do at the very beginning is assemble the information about what you know that you collected in the step before this, right? That information about the data set size, the information about whether it's chunkable, can it fit into batches and what batch size or not, the type of data that you have. You may have image data, you may have video data, you may have data about simulation runs, the type of AI algorithm that you know you're running, or framework that you know you're running, and that information on your collaborators and users. Combine this together with the previous step to guide that AI hardware architecture search. So now that you have a bit of data and you've started to put some things to paper, what do you do with this data about data sets and algorithms, and how do you translate it to our hardware architectures? So let's explore a few different workloads and start to see how they map. If you assess that your algorithm is solely for AI training, and your data set fits within a GPU or a reasonable number of GPUs, say 4 or 8, right? 320 gigabytes maximum for 8 GPUs, or half that for 4, then you probably should be looking at a system like one of these two. This 4 GPU architecture with NVLink, this 8 GPU architecture with NVLink. You get a special training performance increase, and you can fit that entire data set inside of the system. So primarily you want these kind of NVLink connected systems with a GPU count to scale to the size of your data set or your budget. And secondarily, you can think about PCI Express systems that are switched with the same kinds of hardware architectures, not pictured here. Now, there's a bit of a corollary to this for AI training. If you're still only training, but you need really supreme ease of use, the NVIDIA DGX systems, they have superior ease of use, manageability, they have really high performance, and they come with a lifetime of software updates. And those software updates actually improve the system's performance over time. They also come with direct NVIDIA support. And you can see how these also map to different data set sizes, right? The small and then the two larger ones. When you have an NVIDIA NGC certified HGX A100 system with 8 GPUs with paid NVIDIA support, it can provide some of the same advantages of a DGX system, just a different way of consuming that hardware. So you have an 8 GPU system with a more customizable architecture, or you have the branded DGX system with some of those advantages of coming with the full NVIDIA support stack and NVIDIA branded system. Now let's say you have a mixed workload based upon your assessment, or blended workload, or your data set is such that it fits into a single or a small number of GPUs. Well, then a balanced system is probably the best match to the application. You can think about this as being a single CPU with 2 GPUs, or dual socket system with 4 GPUs. People, they often knock this as non-performant, but I would say a majority of the AI systems that we deliver, when we're talking about the volume of systems we ship, i.e. the system count, not the GPU count, they're delivered with this kind of hardware configuration for a mixed workload, because a huge number of users are doing that kind of AI and HPC together workload. They're doing that kind of blended workload or a smaller data set. Well, let's say you have a data set after assessment that simply can't fit into a single GPU, or even the maximum number of GPUs of the system. Well, this is a case for kind of 3 different paths. The first is an 8 GPU system with PCI Express switches. If you can custom code your algorithm to get data into the GPUs at the start and stream that data in over time, or get it all in at the beginning and not have to stream data in, and utilize the PCI Express bus to do this, you might be able to get away with that. The second is a Power 9 system with NVLink. This uses coherency, speaking the same memory space, so that you don't have to manually move data, and you can use the high bandwidth NVLink bus to carry that data from CPU to GPU. It's used in partnership, and the data is automatically carried between the two devices, from the CPU memory to the GPU memory. You don't have to manually manage it. So that's great if your data set is too large. You can let the system do the work, if you will. Or eventually, you may have a data set after assessment that's so large that you need to consider a multi-system configuration. And testing can help you assess that sizing. Then finally, if you have a hand-coded application, you have custom architectures that can be designed to match that code's performance, whether it's something that dangles as many GPUs off of a single CPU as possible, something that's a more balanced architecture but high density, or something where you have a GPU code that is highly accelerated and uses very little CPU power. Then you may want to dangle all of the GPUs off of a single CPU and have PCI Express switches in that case. How about if you don't know what your workload's like, or you can't find out? Well, there's 2 recommendations for what to do in this case. The first, of course, is to test it. You can remote test drive GPUs. We, for example, offer that kind of benchmark resource, but we're hardly one of exclusively ones. You could use a cloud instance for that. Test your workload and test it across a few different system architectures that you think are the most likely based upon the pre-work that you did to date. Then the second is, think about this as, you can't go wrong in some sense, right? If you're upgrading from an earlier generation GPU, or you're upgrading from a CPU-only workload, no matter what your choice of architecture, you're going to have a good, better, best compared to what you might have experienced in the past. The difference between 5 and 10x improvement in performance, it's hugely critical, but both are going to be an immense speed up. So this is going to far exceed any architecture gradation, whether you're upgrading from CPU to GPU, or if you're upgrading from a much earlier, architecture GPU, say Fermi or Kepler or Pascal GPUs. That's going to far outweigh any system architecture choice. So you have thoughts on a hardware architecture. Now what? One of the biggest hiccups for you in the community and the end users that we encounter is finding AI expertise within the vendor community. And most importantly, how you create a successful interaction with someone who can help you once you've kind of identified some candidate system architectures. So let's talk for a few minutes about who, where, and what to look for in that interaction so that you can have a more productive deployment. So think about your last interaction with a vendor. What was your experience like? Did you get to the right people? Getting the hardware architecture you want deployed, it's as much about finding the right people on the vendor side to make this happen as it is identifying the candidate hardware architectures. So here's a small guide on how to do that. The first piece of this is who to look for. You want to look for particular types of people and particular titles. Someone who's a technical salesperson, someone whose title says solution engineer. Anyone who's proven that they know something, if they have tech street cred, you should head in their direction. Anyone who has proven access to testing hardware, similarly, you want to head in their direction because you're going to have a more productive engagement with that kind of vendor than someone who's more generic or simply doesn't have domain skills. So who to look for in the tier 1 vendors and in tier 2 vendors? Well, in tier 1 vendors, you want to find the HPC or the AI groups exclusively. This is really, really difficult. Tier 1 vendors, the HPEs, the IBMs, the Dells of the world, they're vast and sprawling organizations. It can be hard to identify the right HPC and AI people inside there. But if you can, you'll find they're really excellent. You want to avoid, of course, people who are general sellers of Dell stuff, for example, or HPE stuff. They may have laptop or networking type of experience. It's not going to help you when it comes to an AI hardware architecture. And then in the tier 2 world, you absolutely want to find the established AI and HPC vendors and avoid people who are kind of parts resellers or they're limited integration shops. It will seem attractive to work with these people from a cost perspective, but a system that isn't integrated properly with bad components, their ride's not working, isn't going to be a successful deployment for you. It's not going to yield you any value. And similarly, you want to finding established AI and HPC vendors, you can look for some qualifications inside of programs. For example, NVIDIA NPN Elite Deep Learning Partners, they're going to have specific AI expertise and specific experience in architecting systems for AI. So you can test the vendor's appropriateness for you, their commitment, even their technical depth, right? Do a few things with them. Ask for testing and benchmarking resources. See how they respond. If they respond affirmatively or try to do this for you, you know you're working with someone who may be good. Test the vendor by asking to see the hardware architecture that they've recommended, and have them diagram it out, for example, or whiteboard it out. Even back of the napkin would be okay. Is the vendor spending time on the phone, via email, or in person with you? That's usually a good sign. So don't work with someone who just doesn't understand what you're talking about. It's not going to yield you a good deployment. It's not going to yield you good advice. And then once you've found the right people, the right vendor, and you've assessed who you want to work with there's a few pieces of wisdom on how to get a better engagement. The first, is overshare. Every piece of data about your data set, your algorithm, your code, and even your goals is really critical for that vendor to know. And share about what's working today and what's not working today. That can be really instructive on how to kind of shape the hardware architecture. And also overshare about what you own today. Then describe your usage model. Do it in plain English. Like, how do you want to use the system? What do you think is going to be how end users log into the system? Then discuss your collaborators with the vendor. Talk about what do they own? Do you need to plan to run together? And then finally, this is one that we get quite frequently. State realistic plans for flexibility or expansion. It's important to share with your vendor if you think you're going to upgrade this system, for example, to have twice as many GPUs down the road. But keep that, that statement realistic. I can't tell you the number of times that I've been told that we want to highly prioritize the expansion for more GPUs. And unfortunately, the project never got funded down the road and the system was never expanded. And it really wasn't the right hardware architecture for the more limited number of GPUs in the system. So be really realistic about this and grade what's the likelihood of you going out and executing on that plan. So if you have a good vendor, you'll find they'll become a partner in architecting your system. Treat them as an asset to your team and a constructive resource to achieve your goals. So share that data that you have, share the proposed hardware architecture, use the vendor, use them as a resource and a confirmation of the mapping that you've done earlier using this system. And then remote test and benchmark if needed to confirm that you've got it right. So in review, let's talk a little bit about what we talked about today. Again, before you start, understand your workload. What do you know about it? The data set, the algorithms, your collaborators. And then start by putting that data to paper about the balance of your workload and then the information that you've collected about your understanding of your data set, algorithms, and collaborators. Then third, map those workloads to hardware architectures. They could be architectures that we've reviewed here for training, for mixed AI and HPC, or for a data set that's simply too large to fit in a single system. And then fourth, once you've got that information, once you've started to map likely hardware architectures, and it could be more than one, go and take that and collaborate with vendors and see if you can deploy that architecture or use them for better understanding. You know who, where, and what to look for, and then start to use those resources to confirm you've got the architecture right, and test, and then go out and go in confidence having architected the right system for your AI application. So I hope you're a little less confused about how to architect a system for a particular data set, algorithm, or beyond. Maybe you've gained a little confidence in how to architect and select hardware together with a partner. And hopefully you'll see that the best vendors are actually partners in finding hardware. They're not just selling to you, and they're helping you to solve your scientific or your business challenge. They're here to help if and only if you find a good one. So if you'd like to work with us, there's 3 ways you can do that here on the bottom. You can remote test drive a system, remote benchmark. If you know a system architecture that you're looking to pursue, then you can go and submit that. If you want to schedule a consultation to figure this out together, that's great too. If you want more hard technical detail about different system architectures, we actually have a great GPU solutions guide that reviews all of the system hardware architectures that we offer, which is a fairly high percentage of what's on the market today. So gain your confidence to solve this AI hardware puzzle. Remember that the best vendors are our partners and are here to help. And hopefully you've been able to see a system here that can allow you to architect and select that AI hardware for your next deployment.